Hi, welcome back. I guess you've tried the exercise with the Department for Transport ULEV data now. And I'm going to just step through a possible answer for this. So here's PowerBI. No data in it at the moment. We'll get the data. We'll look for the Excel file. And we'll go for the table version. The one advantage of this is it will bring in any types that we've set in Excel, whereas the straightforward Excel version won't always do this. We should be able to load up table 1, and you'll see there a preview of it. These are now the fields. If you loaded the other spreadsheet, don't worry, as long as you've loaded from the wrangled part of the dataset, you're fine. So now, before I do anything else, I'm just going to save this because the Power BI file itself needs saving. If you're using the online version, it'll essentially be auto-saving for you. But we want to save the answer here. DFT, ultra-low emission vehicles, answer 0. Now, how are we going to create a visualization of this? Well, we've seen some of the data already, so I have some idea what's going on. But we know that we want to compare cars here with ultra-low emission cars, not vehicles. So we're comparing like with like. So we'll start off by looking for a histogram. And we will use the time period as the axis. And we'll start off with cars as the values. So per year, this is summing all the cars registered in each year from 2001 through to 2016. I'm going to put a filter on the whole page. And just this page. You can do it for all pages in the report, but I will then keep is before. We're going to go for the 1st of the 1st 2017. And when we apply that filter, what should happen is that this partial 2017 data will be removed from the data set. So there you go. On this whole page, we've done that. Now, we might want to format the page background. I'm just going to go for a pale yellow again. Make it opaque so we can see it. And on this visual, also switch off the background so we can see the visual against the current background. Now, the question is, how do the cars per year compare to the ULEV cars per year? And ULEV cars are this one here. We're going to add that to this visual simply by pulling onto here and dragging and dropping. And you can see, if I make sure I selected all the years, that the tiny little dark zone here is ultra-low emission vehicles, and it's a very small proportion of the total. You can also see that before 2010, there were effectively none. So if we're looking at contrasting the number of cars and the number of ULEVs, the first thing we might do is zoom into that time zone. And so I'm going to filter this visual on year. I'm going to say is greater or equal to 2010. Let's apply that. Okay, so now we've got the data from that time. Now, while I still have this in this form, I'm going to copy and paste it, and you'll see why in a second. So on the one on the left, I'm going to remove ultra-low emission vehicles. On the right, I'm going to remove cars. So now you're starting to see the differences with different scales, because these are auto-scaled. It's important, therefore, to keep the context of the top plot where you can see the ULEV cars are very low in value. Okay, now we can set some trend lines and we can see the trends. On this one, so it's for cars, add a trend line. And for ULEV, we're also going to add a trend line. And just from the slopes of those lines, you can see that the rate of increase of ULEV is much faster than the rate of increase of cars in that time. And in fact, if we scaled it, we probably see that the ULEVs were getting on for a power curve or an exponential curve in increase. What else could or should we do? Well, if we look at the plot above, ULEVs are plotted in black. It's a good idea to keep the same color for the same variable whenever you can and maintain consistency. This helps people track things across visuals. So now we've got blue for cars and black for ULEV vehicles. I'm just going to squeeze up these a little bit because we've got plenty of space. And I want to add in some extra text. Let's use the whole page. And you can see this is important in a number of applications, that just by shuffling things around you can gain space. And very often when you want to add extra things in a visual, you do want to gain space on dashboards. For example, always try and put a title on a dashboard so that people understand what they're looking at. And this is important in a number of ways, one of which is very often people have very little time and need to absorb quickly what it is you're saying. So here we can say car registrations for cars and ULEV cars between 21 and 2016. Okay, now let's just format that so we can read it. 24 point. We might just push this up a bit more. 28 point. Make it bold as well. You'll see the background. We'll switch the background off. Car registrations for cars. Let's make that a bit clearer. Registrations for cars. About registrations properly. Registrations for cars and ULEV cars between 2001 and 2016. Now, okay, so there is this, but what's the key message in the data? So we can use more text boxes in this case to add in some statements about this. So we can say that, okay, so I'll copy and paste the text box so I can move one down here as well. Okay, so there's a potentially finished dashboard on that dataset. We can say that we've got a title, gives us a clear idea of what this is about. We've got a set of graphs which show all the data that we've got and a comparative value of those cars versus ULEV cars with a key to explain the differences. And then two further charts zooming in on the key years between 2010 and 2016, where car sales have increased, but ULEV car sales have increased significantly. So now I'm going to duplicate this page, and we're going to look at forecasting. And we're just going to look at forecasting car registrations. We'll remove the things we don't want for now. And the aim here is really to show you, well, how, in the first case, how easy it is to do forecasting with data in Power BI, and also start to show how forecasting is limited in its ability to predict the future. So we've got this plot, we've got the trend line which we'll remove, and in fact we'll turn this into a line chart. So now you can see the line chart, and it's going from 2010 to 2016. What I'm going to try and do is predict what happened to the car market from 2011. So we'll take the filter off this, and this is all years. So we want to look at forecasting, so we're going to try and forecast some data we know and see if that's going to work out. Can we forecast the future or not? You may be skeptical, but let's see. So we're going to keep everything that is less than 2010, let's say. So we've got the data up to 2009. And so we want to predict from the point in time 2009 forwards what's going to happen to the car market. And you'll see I've got the forecast tab open here. This is under the analytics magnifying glass. We can add that. It will straight away start forecasting things, but let's be a bit more intelligent. We'd like it to forecast in years. We'll be specific. And we'd like it to forecast 6 years ahead. We'll apply that. And we'll ask it to show the 95% confidence interval. You can show more, but that will do. So if you just take the data as is from 2001 to 2009, then predict forwards, you'll see that a simple forecaster will predict a downwards trend. And that's not surprising because the data for the last few years almost showed exclusively downwards trends in the market. But, and of course, as we already know, if we duplicate this, put it side by side, we remove the forecasting we just put on there, and we remove the filter to 2009. This is what happened in reality. Now you'll see the top of these graphs has got a different scale. Just to be comparative, we'll set that to be the same. So you can do this in the y-axis, starting and ending, and by the looks of it, we need to make them both explicitly 2800. Well, the nice thing is if you flick from one visual to another, if it's the same visual, PowerBI will keep the same option open for you. So you can add in 2800 for both of them. Okay, so now they're directly comparable reading across. So that 2600 value is there. Oh, we haven't got the same bottom value on here. So we also need to edit that y-axis. We're going to start, where should we start? It's a good question. So for the most accurate representation, most graphs should start at 0, so that when you're comparing trends, you compare them in the context of the whole range rather than a sub-range. Common trick in newspapers is to blow up a tiny sub-range, and then you think, wow, what a huge dreadful thing's happening, when in practice it's not. So here's our overview. We can see the trend line following on downwards from what, you know, as a human, you'd probably say, well, yeah, that's not such a bad prediction because the car market's falling. But of course, at that point, there's an unpredictable change. Legislation on car loans changes, and suddenly the whole market is stimulated so that we get more cars being registered, having been bought using the lease schemes. So there's both an illustration of how easy it is to do forecasting and perhaps how dangerous it can be if you simply rely on simple models of effects when you don't account for all of the variables that are happening around you. Okay, thank you for watching.